So in this lecture, we will create a queue using linked list, and then we will create enqueue method for this queue to enqueue some elements to this queue over here. So let's get started. So the first step over here is we will create node class. As always, inside init function, we will initialize the value and next reference of this node over here. So we know that init function here takes self and value parameter in case of node. We did this several times in linked list section. So here we are just setting value to the value that comes from the parameter, and we are setting next reference to none. So with this, our node class is complete. Now here I will edit one more standard function of Python to make this node eligible for printing. So we know that to make this node printable, we just need to change the str function. So I will set str function like this. And when we print out this node, it will return the value of this node. Now our node class is finished. The next thing that we are going to do, we need to create linked list class over here. So I will create linked list class like this. So inside init function, we need to set head and tail references to none. So basically what we are doing here, we are just initializing head and tail references and setting them to none. Then what I'm going to do over here, I will just make this linked list iterable, because we will print out the queue over here. So without making this linked list iterable, we cannot print out our queue. So we know that to make this linked list iterable, we just need to edit iter function of the Python. So I will do it like this. So this is our iter function. So basically what we are doing over here, we are just iterating through the linked list and yielding the values of nodes in one list. By using this function, we can make our linked list iterable. So our initial classes are ready. So let's get started to create queue using this linked list class over here. So here I will create queue class like this. Then inside init function of this queue class, we need to initialize an object of this linked list over here. So I will do like this. And inside init function, we are initializing the object of linked list. So self linked list equals linked list. So be careful that here I just wrote it with small letter, because this is the property of queue. This is the instance of this linked list class over here. So with this, the creation of queue is complete, because when we are just creating a queue using linked list, we are just initializing head and tail references and setting them to none. So by calling the object of this linked list class, we are doing it over here. So now you might be interested, what's the time and space complexity for this method over here. The time complexity is 0.1, because here we are just initializing the head and tail references and setting them to none. And the space complexity is also 0.1, because in this case we don't have any element in this linked list over here. Now with this, the creation of queue using linked list is complete. Now the next method that we are going to do, we will create enqueue method to insert some elements to this queue over here. So before doing so, after this method, I will copy the method that we edited in our previous lectures, which is str method, and this makes our queue printable. So I will copy that method and edit it. So in this case, the part of this method we are changing to linked list. So here we made our linked list iterable, so we can iterate through the linked list and join the values like this. So by creating this method, we are making our queue printable. Now the next method that we are going to create over here is enqueue method. So let's continue to create enqueue method over here. We know that when we insert an element to the queue, we are inserting an element at the end of the queue. So in this case, whenever we enqueue an element to the queue, we have to insert it at the end of linked list over here. So to insert an element at the end of linked list, we will create enqueue method over here. So let's declare it. It will take two parameters, self is default and the value. And here, the first thing that we are going to do, we will create a node and assign a value to it. So how we are creating a node? We are creating a node based on this node class over here. We will call that class node. I will name it new node equals node class, and we are setting value to it, and the value that we are going to set comes from this parameter. So I'll copy and paste it here. Now the next thing is we need to add this node at the end of the linked list. So we have two conditions over here. The first condition is if we don't have any node in this linked list. So if we don't have any node in this linked list, we have to add this node and point head and tail references to this. The second condition is if we have nodes in the linked list, then we need to add this node at the end of this linked list. So to check that if we have any node in this linked list, we will check it like this. If self.linkedList.head equals to none, it means that we don't have any element in this linked list. So here we will set head and tail references to this new created node over here. By doing so, we are inserting new node to this empty linked list over here. Now the second condition is if we have any node in this linked list, we need to add this new node at the end of linked list. So to add a new node at the end of linked list, we need to create a link between the last node to this new node and a link between tail to this new node. So how can we do that? So we know that next reference of the tail is the last node's next reference. So we can set it to new node over here. So if we set linked list dot tail dot next to new node, we are creating a link between last node and this new node over here. Then the next step is we need to create a link between tail and this new node over here. So I'll set tail to this new node over here. So with this, we are adding an element at the end of linked list. So here we have completed our enqueue method. So before checking it, let's see what is the time and space complexity for this method over here. Now, as always, we will start from the beginning. So here in the first line, we are creating a node and assigning a value to it. So we know that creating a node and assigning a value to it takes O1 time complexity. So this part will take O1 time complexity. Now the next line of code is we are checking head value. And checking head value and assigning node to head and tail reference takes O1 time complexity because here we are just updating the references. So this part of code over here will take O1 time complexity. Now in the else condition, once again we are creating a link between last node and the new node and the link between tail and new node. So here we are just updating the references, and this means that this part also will take O1 time complexity. Now if we combine these complexities over here, we will get O1 time complexity. So the time complexity for enqueue method in case of linked list takes O1 time complexity. Now the space complexity obviously is O1 because here we are just creating one node and creating a link between this node and head and tail references, or the last node and the tail references. So that's why the space complexity will take O1. Now let's check how this method is working. So here I will create custom queue using queue class. Then I will call enqueue method to enqueue some elements to this queue over here. To make sure that if this is working correctly, I will print out this queue here. So let's save and run our code. You see that it's printed out our queue over here. So first we enqueued 1, then we enqueued 2, then we enqueued 3. So every time we call enqueue method, it's inserting new element at the end of this queue over here. So with this, we have completed our enqueue method. Now in the next lecture, let's see how can we dequeue the element from the queue which is created based on linked list. So see you in the next lecture.